Hello everyone, welcome to chemistry episode number 7, nuclear fusion and fission, or nuclear fusion and nuclear fission. So, nuclear fission is when a neutron combines with an isotope of an element. So, pause the video for a second and see if you can figure out these uh what these letters represent. So, this N and this U. So pause the video right now. Try to see if you could figure out uh with the information we've learned from the previous episodes. So I'll reveal the answer now, and this is supposed to be a neutron, and this is an isotope of uranium. So this is just um basically any isotope of uranium. I'm using it here because it's a common isotope for nuclear fission. And so this diagram on the top is showing the nuclear fission of an isotope of uranium. So a neutron combines with an isotope of uranium, and then we can see this new isotope over here that has one more neutron than this uranium isotope because the neutron combined with it. So then this new isotope is very unstable. So nuclear fission, this new isotope created with the neutron combining uh with the isotope, it's very unstable, and so it immediately splits into two products. So this is nuclear fission, right? This new isotope of uranium is very unstable, and it splits into these two products, and it it's also going to release a few neutrons to achieve more stability and a lot of energy, right? This uranium isotope splitting, it releases a lot of energy and a lot of neutrons, and these neutrons is what makes this process radioactive, right? Because neutrons, they can go through your body. They're called ionizing radiation, right? So the neutrons are powerful enough to make some of the atoms in your body ions, which can mess up a bunch of stuff. If you can recall the previous episodes, ions, which are positively or negatively charged atoms. So that's pretty bad. So that's what gives you radiation sickness, and that's nuclear fission is what was used in the first atomic bombs. Now, nuclear fusion, on the other hand, is basically the opposite. Nuclear fission is an isotope splitting into two, but nuclear fusion is two isotopes coming together. Now, take a second here, pause the video, see if you can name these two isotopes. So, this is a proton, this is a neutron, represented by P and N, respectively. Now, see if you can identify these two isotopes based on what we've learned in the previous episode. So I'll reveal the answer now. Now this would just be a hydrogen 2 isotope, and this would be a hydrogen 3 isotope. Now this would be a hydrogen 2 isotope, as this is hydrogen since it has one proton, and its atomic mass is 2 because you just add up the number of protons and neutrons, which would be 2. And then same case here, one proton, which means it's hydrogen, and then you add up the protons and neutrons, just 3 circles. And now in nuclear fusion, um one, or I guess two, of the isotopes are unstable, and so they combine to achieve a more stable form. Now, in this scenario, hydrogen 3 would be the unstable isotope. Hydrogen 2 is stable. But hydrogen 3 wants to become stable, so it fuses with hydrogen 2, and it creates this isotope, which I'll just give the answer to. This is helium-5, because it has 2 protons, and you add up the protons and neutrons, you get 5. And so this releases a lot of energy, right? In nuclear fission, the thing that releases a lot of energy is the isotope splitting apart. But in nuclear fusion, the thing that releases a lot of energy is two isotopes combining. So this releases a lot of energy. But then this new isotope could be unstable, and so it releases a neutron, or just goes under a version of radioactive decay that we covered in last episode. And in this case, this would be this would be neutron decay, because it's uh it's sending out a neutron, right? The helium-5 sent out a neutron and became helium-4, which is stable. So, just to recap, nuclear fission, it's when an isotope uh, gets an additional neutron, and then it's really unstable, and then immediately decays into two products, and it splits apart into two products and releases a bunch of neutrons and energy. And nuclear fusion is when two isotopes combine together. Nuclear fission, an isotope splits apart. Nuclear fusion, two isotopes come together. That releases a lot of energy, and they're this new isotope is also unstable, so it'll go under a version of radioactive decay. And I also forgot to mention nuclear fusion. It's used in hydrogen bombs, right? The later versions of atomic bombs. The enormous impact of hydrogen bombs and atomic bombs too is this energy that's released, right? It's energy. And the radioactiveness, uh, like I said, nuclear fission is because of these neutrons, and the nuclear fusion, nuclear fission is because of these neutrons, and nuclear fusion is because of the radioactive decay, right, which is most likely neutrons. And nuclear fusion is also what powers the sun. So the sun has a bunch of hydrogen isotopes, and the sun it combines these hydrogen isotopes into helium-5, then and that releases a lot of energy, which is why the sun is so hot and bright. And then it immediately decays this helium-5, and it sends off a neutron, and that's why you need to wear things like sunscreen, because the radiation from the sun released by this nuclear fusion, right, it can be bad for you. And so I think that's just about it for chemistry episode number 7, and I'll see you next time.